Hey, it's Ashlee from Smart Addition Academy. I'm here with you today to go over some Accuplacer Advanced Algebra and Functions, or the AAF section of the Accuplacer exam. We're going to do a bunch of practice questions from each of the different topics on the test. So if you need to practice your advanced algebra and functions, this is the video for you. So before I jump into it, make sure you check out the link in the description of this video for more practice questions, a free online practice test, and our full online course from Smart Addition Academy. Okay, so let's jump into it today. We're going to have some practical examples of what you might see on this exam. So here's what we're going to go over today. All right, these are the topics that are on the AAF section of the Accuplacer exam. So we're going to go through, I'm going to give you some tips about each section, each topic in the section, and we're going to do an example problem. Okay, so linear equations. A couple things we need to know with linear equations. So important that we know slope-intercept form, which is y equals mx plus b, where our m is our slope and our b is our y-intercept. Also important to know is point-slope form, y minus y1 equals m, and then in parentheses, x minus x1. So this is where we have our slope, and then we can plug in a point, x and y. Okay, we plug it into our x1, y1, and then we can solve. So depending on the question, you would have to use one of these different formulas for our line. So let's look at an example. Find the equation of a line parallel to y equals 2x plus 5 that goes to the point negative 4, 3. So a couple things we need to know here. A parallel line has the same slope. So we already know our slope, and it goes to the point negative 4, 3. So two different ways to do this. We could either plug into our y equals mx plus b. We'd have to go find the y-intercept, or we could plug into our point-slope form. So for this example, it actually seems easier because we know our slope and we know a point. So if I go ahead and plug this in, y minus y1, so that's our y value of 3, equals the slope, which is the same, so that's 2, times x minus, and then our x value is negative 4. So minus a negative 4. We could clean this up a little bit by just knowing that minus a negative is actually plus. So this is the equation of our line, but if, say, we needed to plug this into our y equals in order to graph it, our slope-intercept form is better for that. So we can actually convert straight from here by distributing, and we get 2x plus 8, and then add 3 to both sides to move that over, and we get 2x plus 11. So you also could have done this using slope-intercept form, but for the way this question was worded, this one was actually a little bit easier. Okay, so that's just an example of what you might see in your linear equations section. There also is linear applications and graphs. So let's look at a couple of those examples. Find the equation of a line perpendicular to this line that passes through the point 0, 1. So perpendicular lines do not have the same slope, but they actually have slopes that are negative reciprocals. Okay, so what that means is if we find the slope of this line, which we can do by going 1, 2, let's see, what do we have to do? Actually, 1, 2, 3, oh, here's the point, sorry. Go 1, 2, 3, 4, go down 4, and then go over 1, 2, 3, 4, 5. So the slope of this line is down 4 over 5. So that can be represented by negative 4 over 5. Now, to turn that into the negative reciprocal, we're going to flip it and make it positive. So our new slope is going to be positive 5 over 4. And now this goes through the point 0, 1. So two things that we could do. We could either plug it into our point-slope form or our slope-intercept form. So they give us a point of 0, 1. Okay, so that means over 0, up 1. So that's actually our y-intercept that they gave us. Our y-intercept here is b equals 1. So I'm going to use y equals mx plus b and plug in my new slope, and then my y-intercept of 1. Okay, so taking a graph and figuring out the equation of a line that's perpendicular to it. Here's an application problem. At Benny's Cafe, a mixed green salad costs $5.75. Additional toppings can be added for 75 cents each. which function could be used to determine the cost, C of S in dollars, of a salad with S additional toppings? So here, we need to figure out, notice how all of our answers follow this y equals mx plus b form. So from this application problem, we need to figure out which one is our slope and which one is our y-intercept, so to speak. So it costs $5.75, and then for each additional topping, it's 75 cents each. So notice how S represents the toppings. So S here, right, all of the S's, should be multiplied by 75 cents. So I can actually get rid of 1 and 3. So I know that my slope is 75 cents, okay? And then my y-intercept is how much it cost initially for the salad, which is $5.75. So if I match this up with the appropriate function notation, sorry, that should be C of S, that would equal 0.75S plus 575, which looks like option number 2. All right, our next topic is factoring. So factoring is a big topic. You're going to need to really be comfortable with lots of different strategies. So strategies to know. We can pull out the GCF of something. Say we have like 3x plus 6, and we need to factor it. All we have to do is pull out the 3, and then we're left with x plus 2, and that would be our factored form. Okay, it gets more complicated when we're dealing with quadratics and bigger numbers, but it's important to always check for your GCF to start. Product sum method is really good when we have something like x squared plus let's say 3x plus 2, okay? Product sum method, which we will practice in an example later, basically tells me, well, I know it needs to multiply to 2 and add to my middle term of 3, so I can figure out my factors that way. In this case, it would be 1 and 2. Difference of perfect squares, or DOPS, is great when we have a binomial that looks something like this, x squared minus 16. So x squared and 16 are both perfect squares, and the difference comes in here with a minus sign. So there is a strategy in order to factor that. Completing the square is really helpful if we have something that doesn't factor using the product sum method very easily. So then we can complete the square. And then last but not least, split the middle, or what I call the earmuff method, is really helpful if we have a coefficient in front of the x squared. So maybe it's something like this. Okay, so all of these strategies are really helpful. If you want a more in-depth video about any of these strategies, leave me a comment so that I can come back and I can do videos that really dive into each of these different topics. So here's a couple examples. So we're going to factor the following quadratic expressions. X squared plus 6x plus 8. So if I'm going to factor this, this is a good example for the product sum method. So I draw my x, and when I'm factoring, I need it to multiply to 8 and add to 6. So factors of 8 are 1 times 8 or 2 times 4. So the ones that add to 6 is 2 times 4. They can both be positive because 2 times 4 is 8 and 2 plus 4 is 6. So what I do is I draw my parentheses. The x squared gets broken up into x times x. And then my factors I just found are plus 2 and plus 4. So that is my factored form of that expression. So that's great. What happens if I need to do something like split the middle because I have a coefficient in front? Okay, so it's going to be a similar process, but I call this the earmuff method because I actually have to take the 6 and the negative 4, and I have to multiply them. So notice how it kind of looks like some earmuffs. So 6 times negative 4 is negative 24. So I need it to multiply to negative 24 and add to 5. So factors of 24 are 1 times 24, 2 times 12, 3 times 8, 4 times 6. The only one that has a difference of 5 is 3 and 8. So I need it to add to a positive 5, so I need the 8 to be positive, and then the 3 can be negative. So what that allows me to do is split the middle. So I'm going to rewrite this as 6x squared, and then the 5x I'm going to rewrite as plus 8x minus 3x. That's what these were for. Minus 4. And now I can just split these into two separate sets of terms to find the GCF of. So 6x squared and 8x, I can pull out a 2x, and I'm left with 3x plus 4. And then negative 3x minus 4 only has a GCF of a -1. So I'm going to pull that -1 out and get 3x plus 4 here. And that's key because I need to have the same thing in my parentheses. So I pull that out, 3x plus 4. And what's left over is 2x minus 1. Okay, so we factored that using split the middle. Again, if I'm going a little bit fast for you and you're like, oh, this is like kind of a tricky topic, I need a little more support with this, please leave me a comment. I can go over this in a lot more depth and not so quick if you guys need it. So our next topic is along the same lines with quadratics. One thing that we can do with quadratics is factor, right? So we can factor, we just practiced that a little bit. We also may need to solve, or sometimes we see that as finding solutions, roots, or zeros. We may also need to graph or do application problems of your quadratics. So a big tip I have for different quadratics is know how to use the quadratic formula. Okay, so this quadratic formula can allow you to find solutions for any quadratic equation. So let's look at a couple examples. Let's solve the following quadratic. 2x squared equals 4x plus 1. So in order to do this one, let's practice the quadratic formula. So x equals negative b plus or minus the square root b squared minus 4ac all over 2a. In order to figure out, well, what is my a, b, and c, I need this to be in standard form. So I'm going to move everything over to the left. 2x squared, it would be minus 4x minus 1 equals 0. It needs to be equal to 0. That's key to find those solutions or those roots. So my a value is 2, b is -4, c is -1. Now when I go and plug this in, you know what, I actually need a little more space. So let me give me a little more room here to do this. Go. Okay. So let's go ahead and plug in. So we have x equals -4, right? B is -4, so we have to have -4 plus or minus square root of b squared minus 4. The a is 2. The c is -1 all over 2 times 2. And now it's just a matter of simplifying. So -4 is a +4. Then what happens under my radical? So I'm going to use my calculator to simplify all of this stuff. So -4 squared minus 4 times 2 times -1. And you can break this up into different steps if that's helpful for you. I'm just going to do it in one step. And I get the square root of 24. And this is all over 4. So from here, the last thing I need to do is see, can I simplify the square root of 24? So the square root of 24 would be not a perfect square. So I just have to check, are there any perfect square factors of 24? And actually 4 is one of them. So off to the side here, let me just show you the square root of 24. We can break into square root of 4 times the square root of 6. And square root of 4 is really just 2. So this can simplify to 4 plus or minus 2 square roots of 6, right? Because that's what's left over, all over 4. And to simplify that, you just get 1 plus or minus 2 over 4 is a half. And this would, I could actually just write as the square root of 6 over 2. So 1 plus or minus the square root of 6 over 2. All right, so kind of a lot going on there when we use the quadratic formula. Happy to do another video if you guys want me to go a little more in depth. All right, let's look at one application problem for quadratics as well. So a ball is thrown into the air from the edge of a 48-foot high cliff so that it eventually lands on the ground. The graph below shows the height y of the ball from the ground after x seconds. So here's our graph. It tells us it is at 48 feet on the cliff. So that's our 48 feet right there, our y-intercept. It goes up and then it starts to come down. So lots of questions that they could ask you here. For example, at what point does the ball hit the ground? So we need to be able to look at a graph and see what it means in relation to the problem. So if this is a ball, it's going up, 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 coming down, 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 and down. It's going to hit the ground at a height of 0. So this would hit the ground when x is equal to, it looks like 5.5, right? Another question they could ask you is, at what point is the ball at a height of 80? So 80 is here. So at what height, or at what point, I'm sorry, is the ball at a height of 80? Well, it looks like when we are at 1/2 and 4.5. So that's when x equals 1/2 or 4.5. So lots of different questions they could ask you. We need to know how to look at a graph and pull out important information from that based on the question. All right, our next topic is functions. So functions are really important. You need to be able to see what is a function based off of a few different types of ways they'll show it to you. They may show it to you in a table, a graph, a set of coordinates, or an equation. So which representations are functions? So function means that there are no repeat inputs. So the input is the x value. You need to make sure the x does not repeat. Okay, so if I'm looking at a table, does the x repeat here at all? Well, I do see 2 twice with 2 different y values. So that means that that is not a function. So number 2, do I have any x's that repeat? It doesn't look like it. My y's repeat, 1 and 1. But that's totally fine. That is allowed, but our x's cannot repeat. So this one works out. 3, is this a function? Well, now we don't have the actual numbers or coordinates, but we can use what we call the vertical line test when we are using a graph. And that just means if we draw a vertical line anywhere on the graph, if it hits more than once, which this does pretty much everywhere on the graph, then it is not a function. So this does not pass the vertical line test. If you think about something like a line, a linear equation, this one would pass the vertical line test because it'll never hit more than once. Okay, and lastly, if we have an equation, y equals 2x plus 1, this would be a function because any x value you plug in will give you a new y value. So our 2 functions are option 2 and option 4. All right, and now another thing for functions is you have to be able to plug in and find the value of a function. So f of 4, f of negative 2, and f of 2/3, we need to find those if f of x equals negative 3 plus 5, negative 3x plus 5. So f of 4 would be negative 3 times 4 plus 5. Negative 3 times 4 would be negative 12 plus 5. That'll give me negative 7. All right, maybe you can try this next one. So maybe pause the video and let me know in the comments, what do you get for f of negative 2? I'm going to plug in negative 3 times negative 2 plus 5. Negative 3 times negative 2 is 6, plus 5 gives me a positive 11. And then one with a fraction, just because we all love fractions. Negative 3 times 2/3 plus 5. Well, negative 3 times 2/3, I can just multiply across the top and the bottom. Negative 3 times 2 is negative 6. Over 3 will just give me a negative 2 plus 5, which is a positive 3. Okay, so there are a few things you need to know for functions for the Accuplacer exam. All right, radical and rational equations is another thing we need to practice. So we need to solve maybe something like this. 3 over x plus 2 equals 5 over 2x minus 1 if x does not equal 2 and x does not equal 1/2. Actually, this should say x does not equal negative 2. Sorry, I think I had a typo there. X does not equal negative 2 and x does not equal 1/2. So if I'm trying to solve this, one way to do this would be to cross multiply. So 5 times x plus 2 has to equal 3 times 2x minus 1. So I'm going to distribute 5x plus 10 equals 6x minus 3. And in order to get x by itself, maybe I'll subtract 5x from both sides. And then add 3 to both sides. And I will get 13 equals x. So that is my value of x. That solves that equation. Now, how do we solve an equation with a radical? So this shows the square root of 3x plus 7 equals 4. So my goal is still to get x by itself. So in order to undo the square root, we actually can just square both sides. So that would leave me with 3x plus 7 equals 16. And then I just have a pretty simple equation to solve. 3x equals 16 minus 7 is 9. And when I divide by 3, I get x equals 3. Right, so a couple examples of some radical and rational expressions. And we are moving right along to our next topic of polynomial equations. So let's solve something like this. 2x squared plus 4x plus 5 minus 3x squared plus 4x minus 11 equals negative 9. So first thing is to get rid of this minus sign here. So we need to distribute this. So the first set of parentheses can just stay the same, but when I distribute this negative sign, I get negative 3x squared minus 4x plus 11, and that equals negative 9. Okay, and then from here, now I can combine some like terms. 2x squared minus 3x squared is a negative x squared. Plus 4 minus 4 actually cancels out to be 0. And then plus 5 plus 11 is plus 16. This equals negative 9. Now I will subtract 16 from both sides, and I get x squared, negative x squared equals negative 25. Divide by negative 1. X squared equals a positive 25. So the last step is to get rid of the x squared. I can just take the square root, and I will get x equals, and it's important when we take the square root of a number, the answer is either plus or minus the square root, which would be 5. So our solution would be plus or minus 5. So solving polynomial equations, you may have to distribute a negative sign, combine like terms, and then at the end, you may need to take a radical, like the square root or the third root, in order to find the solution. All right, exponential and logarithmic equations. So a few examples of things you need to know. Let's try to solve 3 to the 3x plus 4 equals 9 to the 2x. In order to do this, we need the same base. So 3 to the 3x plus 4 can equal 9 can be written as 3 squared. So this is the key to this question. I can rewrite this as 3 squared to the 2x. And then what that allows me to do is say 3 to the 3x plus 4 equals 3. 2 times 2x would be 4x. So because I have the same base, the exponents must be the same. So 3x plus 4 has to equal 4x. And when I subtract 3x from both sides, I get x equals 4. So let's look at the next example. Now we're going to take logarithms and go back and forth between exponential. So let's solve the following. Log to the base 2 of x equals 3. So in order to solve this and get the x by itself, I need to rewrite this as an exponential. So how I can do this is the base is 2, and the exponent is always going to be what's on this side. So 2 to the third equals x. And when I do 2 to the third, that is equal to 8. So this just is x equals 8. And you could plug this in and check log base 2 of 8 equals 3. Now, if I have an exponential and my variable is stuck up there and I need to solve for that variable, I can write this as a log. So log to the base 2 of 7 is going to equal 5x. Okay, so we could solve for that. And then I could just divide each side by 5. And I would find that x equals log to the base 2 of 7 all over 5. And say this is a multiple choice question. This is exactly what your answer would look like. Okay, so it's not pretty, it's not simple, but it is just a value where if you had a graphing calculator or some higher functioning calculator, you could plug this in and get the value of that. Okay, so it's important to know how to convert back and forth between logarithms and exponentials. So again, if that's something that you're like, hey, pause the video right there, I need some more help, leave me a comment and I will make a new video about that. Okay, and we have our last topic. We're running out of time a little bit, so I'm going to fly through some trigonometry. Then one thing I really want you to know and have memorized is SOHCAHTOA. So SOHCAHTOA, what does that mean? Well, that is our 3 main functions, sine, cosine, and tangent. And with trigonometry, a lot of times we're talking about right triangles, and that helps us remember the sine, cosine, and tangent functions. So sine is going to be the opposite side over the hypotenuse. Cosine is going to be the adjacent side over the hypotenuse. And then tangent is going to be the opposite side over the adjacent side. So what does that mean? Let's look at an example. In a right triangle, there is an angle x such that cosine of x equals 3 over 5. Find the value of sine x. So if I have a right triangle, and I say this is x, okay? If cosine of x equals 3 over 5, well, SOHCAHTOA, this is adjacent over hypotenuse. So that means that 3 is my adjacent side, and my hypotenuse is 5. So I need to find the sine. So the sine of x is going to be opposite over hypotenuse. So I need to find this in order to find the sine. Now, from your geometry skills, we know how to find the side of a right triangle by using the Pythagorean theorem. See if that rings a bell. A squared plus b squared equals c squared. So I can just plug in what I know. 3 squared, I'll solve for b, equals 5 squared. So I get 9 plus b squared equals 25. Subtract 9 from both sides. B squared equals 16. And when I take the square root, I get b equals 4. So that's the value I needed to help figure out the sine of x, which is the opposite side, right across from it, over the hypotenuse, which is always across from the right angle, the longest side. And my value would be 4/5. Okay, so we did a lot of examples in this video today. I hope you found them helpful. And if you want more practice like this, make sure you check out the links in the description of this video for our online practice test, which you can get for free at Smart Addition Academy, as well as our full online course. So I hope this helped. Check out our other videos for the Accuplacer exam. We will have more example problems like this for you to practice. So have a great day and happy studying.